The sky isn't the limit, it's the playing field. And on that field, rules are written in blood, tested in fire, and enforced by men in clean shirts who've never felt the G-force of their own bureaucracy crush a dream. They told him it couldn't be done. They said the metallurgy was fiction, the thermodynamics a fantasy, and the very idea a one-way ticket to a catastrophic failure report. They banned it, paper-clipped it into oblivion. And then, on a morning so calm the sea was a sheet of polished glass, he proved them all wrong in the most violent, beautiful, and undeniable way possible. He outran 7 zeros at sea level, not in the thin, forgiving air of altitude, but down here in the thick, choking soup of reality where physics is a brutal and honest judge. This is a story about the line between genius and insanity, between regulation and stagnation, and what happens when someone is so right that every established authority is, for a glorious moment, completely and utterly wrong. But here's my question to you. Before we dive into the grit and grease of this, have you ever looked at a rule, a policy, or a so-called standard operating procedure and known deep in your bones that it was fundamentally flawed? Not just inconvenient, but wrong? I want you to think about that. Seriously. Pause for a second. Maybe it was a TSA agent making you throw out a perfectly safe item because of a misunderstood guideline. Maybe it was an airline policy that defied all common sense. That feeling in your gut, that quiet certainty against the roar of institutional authority, that's where our story begins. I want you to share your experience in the comments below. Tell me about a time you knew the rule was wrong. Because understanding that feeling is key to understanding everything that comes next. Stick with me, and I'll show you why that instinct matters, not just at an airport security checkpoint, but in the very engines that push us beyond the horizon. This isn't just a tale of engineering rebellion. It's a masterclass in how systems work to protect themselves and how a single person, armed with nothing but truth and a relentless drive to prove it, can temporarily shatter that system. To understand the sheer audacity of outrunning 7 zeros, a phrase I'll unpack in brutal detail, you first have to understand the cathedral he was trying to burn down, the world of aviation certification. Think of the Federal Aviation Administration not as a government office, but as a slow-moving, incredibly powerful organism whose sole immune response is to say no. Its DNA is written in accident reports. Every line in the Federal Aviation Regulations, every advisory circular, every stipulation from a type certificate datasheet exists because someone, somewhere, died. That's the somber truth. The rulebook is a gravestone with footnotes. So when an engineer, let's call him Leo, though that's not his real name, walks in with schematics for a radical modification to a proven turbine core, he isn't just presenting data. He's asking the guardians of the tomb to carve a new epitaph. Their job, their very purpose, is to assume he is a well-meaning fool whose ideas will fill a new page in the accident ledger. The default is rejection. The burden of proof is so astronomically high it might as well be in orbit. Leo's modification centered on the high-pressure turbine section. I won't drown you in jargon, but you need to grasp the ballet of brutality happening inside a jet engine. Air is sucked in, squeezed by spinning compressors until it's hot and furious, then doused with fuel and ignited. This expanding volcanic gas then smashes into the turbine blades, spinning them at speeds that would fling the metal apart through centrifugal force alone. These blades are miracles of material science. Cored with internal cooling channels coated in thermal barriers, often grown as single crystals to avoid weak points. They operate in a hellscape far above the melting point of the metal itself. The margin between peak performance and catastrophic uncontained failure is measured in microns and milliseconds. Leo looked at the standard blade design and saw inefficiency, not in the shape, but in the cooling. The conventional method is like using a fire hose on a campfire. It works, but it's wasteful. That spent cooling air dumped into the hot gas path disrupts the smooth flow of energy. His idea was a subtle, almost elegant redistribution, a recalibration of how and where this cooling air was introduced and exhausted. It wasn't a new material, it was a new pattern. In simulations, it promised a few percentage points of increased efficiency. In the world of turbine design, that's not an improvement. It's a revolution. It's the difference between a plane that needs a fuel stop and one that doesn't, between a payload that's limited and one that's profitable. He took it to the board, the Engineering Review Committee, a group of men with decades of experience and, crucially, professional liability, examined it. They saw the simulations, and they saw risk. The new channels could clog. The altered thermal gradients could create new stress points. The certification testing alone would cost millions, with no guarantee of success. Their existing engines were reliable. They met all regulations. The financial and regulatory inertia was a mountain. Their verdict? Banned. Not for testing, not for research. Banned from further company resource allocation. The project was to be closed. His designs were shelved. In their eyes, they'd avoided a potential disaster. In his, they'd condemned a certainty of stagnation. This is where Leo stopped being a company engineer and started becoming a legend. He quit. He mortgaged his house. He turned his garage into a machine shop that would make a NASA technician weep. And he began to build not a whole engine, but a single turbine blade. His blade. He sourced the proprietary alloys through contacts in the industry, a gray market endeavor that itself skated the edge of legality. He used precision casting equipment he built himself. For 2 years, every night and weekend was consumed by the creation of this one perfect, forbidden component. Meanwhile, let's talk about those zeros. In aviation performance, especially military aviation, outrunning zeros refers to a very specific and terrifying scenario, engaging and escaping from multiple enemy aircraft, typically McCoy and Gurevich MiG fighters, designated with zero in their NATO reporting names, like MiG-29 Fulcrum. To outrun 7 at sea level is the stuff of myth. Sea level is where the air is densest, creating maximum drag and maximum stress on an airframe and engine. It's where your fuel gulps are the deepest, your heat buildup the most intense, and your margin for error the slimmest. An engine that can deliver sustained, unprecedented thrust at sea level is an engine that defies the known performance envelopes. It's not just better, it's alien. Leo's opportunity came from a place of desperation, not strategy. A private military contractor, operating on a blurred line, had a problem. They were flying covert surveillance flights with a small, modified business jet, a type you've probably seen at airports and thought nothing of. It was fast, but not fast enough. Their intelligence suggested the threat environment had changed. The skies they once slipped through quietly now had new, faster guardians. They needed more power. Not next year, now. And they had the budget and the operational secrecy to bypass the usual channels. Word of a brilliant rogue engineer with a magic blade reached them through the whispers that always travel through such communities. They found Leo in his garage, surrounded by schematics and the sweet, sharp smell of cutting oil. They didn't want reports. They didn't want certifications. They wanted a result. They provided him with an engine, a Pratt & Whitney Canada JT-15D, a common turbofan on smaller jets. They gave him a hangar, and they gave him one instruction: make it work. What followed was 60 days of focused insanity. Integrating his single modified blade into a full turbine rotor is like replacing one violin string in a symphony and expecting a more beautiful sound. The balance had to be perfect. The clearances had to be exact. The engine's full authority digital electronic control, FAA, had to be subtly, carefully tricked. The FAA is the brain. It expects certain parameters from the engine's body. Leo was giving it a new set of lungs. If the FADEC sensed something too far out of bounds, it would reject the data, or worse, default to a safe, low-power mode. This was a dance with the digital ghost in the machine. The test run was conducted in the dead of night in a remote coastal location. The engine, mounted on a heavy test stand, spooled up. The whine built from a shriek to a world-eating roar. Instrumentation feeds glowed with numbers. The thrust output climbed past the manufacturer's rated maximum and kept climbing. It stabilized at a level 12.7% higher than spec. The temperature margins were healthy. The vibration harmonics were within tolerance. It wasn't just a success, it was a freak of nature. The contractor's team, hardened operatives who'd seen everything, just stared at the data screen in silence. The modified engine was installed on the sleek, dark-painted jet. The mission profile was simple: a high-speed sea-level dash over a long, isolated stretch of ocean, monitored by chase planes and radar. The 7 zeros were not real enemy aircraft, of course. That's a dramatization. They were performance metrics, simulated threat envelopes based on the capabilities of the latest generation of fighters. The test was to see if the jet, with its new heart, could accelerate and sustain a speed that would outpace the theoretical pursuit curve of 7 separate threat aircraft in a dense, low-altitude environment. The pilot lit the engines and released the brakes. The jet seemed to leap forward, as if pushed by a giant, unseen hand. Acceleration was visceral. As it dipped down to skim the wave tops, the airframe groaning under the pressure, the pilot pushed the throttle to its stop. The modified engine didn't just deliver power, it delivered it with a smooth, relentless fury. The chase planes, themselves no slouches, were left behind as if they were standing still. Radar clocks confirmed it. The jet reached and held a speed at sea level that the original design specs said was impossible by a wide, laughable margin. It didn't just outrun the simulated threats, it rewrote the book on what that airframe was capable of. In that moment, over that dark ocean, every risk assessment, every committee review, every banning order was rendered obsolete. Now, you might be thinking, great story, but what's this got to do with me and my suitcase at Terminal B? Everything. Because the mindset that banned Leo's engine is the exact same mindset that governs your travel experience every single day. It's the philosophy of risk aversion, institutional inertia, and the supremacy of the checklist over context. Let's bring it down to earth. You're at a TSA checkpoint. You have a common item, let's say a large, unopened jar of gourmet salsa. It's a gel, over 3.4 ounces. The rule says it must go in your checked bag. You know it's safe. You can see it's sealed. But the officer sees a jar of liquid over the limit. Their training, their protocol, their metric for success is adherence to the rule, not the exercise of judgment. To them, your salsa jar is Leo's turbine blade, an anomaly that represents unknown risk. Their immune response is to say no. They are not paid to be aerodynamicists. They are paid to follow the SOP. So your salsa gets tossed or you miss your flight running back to check your bag. The system has worked perfectly from its perspective. It has eliminated a potential, though absurdly minuscule, risk. It has also created a frustrated traveler and wasted a perfectly good jar of salsa. This is the ban on a micro scale. Or consider the airline gate agent facing a weather cancellation. The rebooking system is a labyrinth of algorithms and rules. You have a compelling human reason to get home, a sick family member, a critical meeting. The agent's authority is bounded by what their computer screen allows. To grant an exception is to step outside the system, to accept personal and professional risk. Most won't. The rule, the algorithm, is safer. It's the committee banning the innovation, because the known misery of hundreds of rebooked passengers is less risky, career-wise, than the unknown outcome of making a special case for one. The genius of Leo's story isn't that he broke the rules. It's that he proved the rules were inadequate. He provided irrefutable physical evidence. You can't do that with your salsa jar. But you can understand the dynamic, knowing that the person in the uniform is often not the enemy, but a cog in a system designed for the worst-case scenario, changes how you approach the situation. Your goal isn't to win an argument about the physics of salsa, it's to navigate the system as it exists. This is where traveler wisdom comes in. The engineers banned the mod because they couldn't see past the potential failure modes. The successful traveler learns to see past the rigid front of the rule to the intent behind it. The intent of the 3.4-ounce liquid rule is to prevent the smuggling of liquid explosives in dangerous quantities. Knowing that, you pack accordingly. You don't try to argue about the seal on your shampoo. You check your large liquids. You arrive prepared. You manage your own risk to avoid triggering the system's no response. But sometimes you encounter a rule that is simply misapplied. I once saw a TSA officer try to confiscate a small, solid block of carbon fiber used for a camera mount, claiming it was a tool. It was clearly not. I watched the traveler, a photographer, calmly ask to speak to a supervisor. He did not get emotional. He did not cite the rulebook. He simply explained, clearly and respectfully, what the item was and its purpose. He presented it as a clarification, not a confrontation. The supervisor, with more experience and slightly more latitude, overruled the officer. The item was allowed through. That traveler was, in his own small way, being Leo. He had a deeper understanding of the item than the first-layer enforcer did. He appealed to a higher authority who had the capacity to see beyond the checklist. He didn't outrun 7 zeros, but he outran one mistaken confiscation, and that made all the difference to his trip. The aftermath of Leo's sea-level dash was messy, as truth often is. The contractor had what they needed, but now there existed a physical, proven technology that the official channels had declared impossible. Whispers became rumors. Rumors became reports. The original manufacturer got wind of it. Can you imagine the boardroom meeting? The very modification they had banned for being unsafe and impractical was not only built and tested, but had performed spectacularly in the most demanding environment imaginable. The legal and intellectual property implications were a nightmare. The potential liability if the design did have a flaw that led to an accident was astronomical. They had two choices: sue Leo into dust to bury the technology and protect their institutional credibility, or bring him back in, legitimize the work, and begin the agonizingly slow process of certification. They chose, surprisingly, the latter. It was the colder, more corporate calculation. The potential profit and performance advantage now had a proof of concept. The risk had been, in part, absorbed by a third party. Leo was offered a return with a new title, a new lab, and a team to do the years of testing required to get an FAA supplemental type certificate. He took the deal. The Rebel was absorbed back into the system, but he had irrevocably changed it. His blade, or the principles behind it, eventually filtered into new engine designs. The ban was replaced with a program. The revolution was bureaucratized, but the performance gain was real. This is the ultimate lesson for any traveler, any person dealing with a large, impersonal system. Proof is the only language that ultimately matters. Your feelings, your logic, your perfect understanding of the salsa-based threat model are irrelevant. To change the outcome, you need evidence the system is designed to recognize. For Leo, it was terabytes of flight data and a radar track. For you, it might be a printed copy of the airline's contract of carriage when they claim they don't owe you a hotel room for an overnight cancellation they caused. It might be knowing the exact phrasing of the TSA's policy on medical devices. It might be the simple, undeniable evidence of being at the gate on time when they claim you were late. Don't just know the rule. Understand why the rule exists. Then, if you must challenge it, speak the system's language. Be calm, factual, and persistent. Ask for the supervisor. Know your reference points. You will not always win. The system's inertia is massive. But sometimes, if your case is solid and your proof is clear, you can get that supervisor to see past the checklist. You can get the gate agent to find the loophole in the algorithm. You can, in your own small way, outrun the zeros that are arrayed against you. The zeros of indifference, of bureaucracy, of reflexive no. The next time you're in an airport, remember Leo. Remember that the rules around you are written in the blood of past disasters and the ink of liability fears. They are not necessarily wise, but they are powerful. Your job is not to be a rebel without a cause. Your job is to be a savvy navigator. Pack your bags with the intent of the rules in mind. Carry your proof, pick your battles, and know that occasionally, very rarely, someone comes along who changes the rules forever by proving them wrong in a way that cannot be ignored. They outrun the zeros, not through defiance alone, but through undeniable, verifiable truth. Until you have that kind of proof, the smart move is to play the game better than anyone else. Check the salsa, smile at the agent, and know that the system is what it is. But also know that it's not always right. And that knowledge, in itself, is a kind of power. Safe travels.